So in this video, we're going to talk about factoring by grouping, and let's get started. But I do want to tell you that at the end of this video is one of the kind of more intriguing types that you may see. And so be sure you get to the end so that you can see that one. And then I will continue on. And so I think I'm going to start this whole thing over. Anyway, so we're going to stop here for a second. I'll start over. And then we'll start again. Okay, in this video, we're going to talk about factoring by grouping. I do want to point out to you that the very last problem that we're going to do has a often seen kind of a pattern, and it has a crucial thing that you need to understand about what to do with that pattern. So be sure you get to the end of this video before you stop watching. All right, now, so here we go. So we've got these four terms. Usually when you're factoring by grouping, there's four or more terms, and so you look at various strategies to kind of group them together and then to factor out what's in common. So factoring by grouping says, okay, let's look these over. There's four terms. There's nothing in common to factor out. There's not any like terms because they're similar. I mean, they're not even, they don't fit the qualifications of math, which is similar, but what they do is they've got some characteristics that are the same, but they are not like. Okay, so 2xy's is not the same thing as 5xc's, for example. All right, so what we're going to do is to group the front two and to group the back two. That's the kind of more traditional factoring by grouping technique. So you look at the front two and say, what's in common in the front two? Well, they're both even, so there's a 2 in common. They both have a y, so there's a y in common. And you factor that out as if the back two were not there. So if you have 2xy and you factor out 2y, you have x left. And if you had 8y and you factor out, which is to divide out 2y, you have 4 left. And you can always check these, and you should. It takes you just a few seconds and go, all right, let me make sure that's right. Does 2y times x get you back up to this original? Yes, it does. Does 2y times 4 get you back up to this one? Yes, it does. So it takes you like 5 seconds to double check, and it saves you getting all the way down to the end problem to go, this isn't working out right. Let me go back and look at it all over. All right, now you look at the back two, and you say, is there anything in common between a 5xz and a 20z? Well, 5 is in common, and z is in common. And most often you pull this sign right there. So you would go, all right, I'm going to factor out a plus 5z, and you're going to see what's left. So if you have 5xz and you divide out or factor out a 5z, you have x left. And if you have 20z and you divide out a 5z, you have plus 4. And you would double check. Does 5z times x get you 5xz? Yes. Does 5z times 24? Does 4 times 4 get you 20z? Yes, it does. All right. So this is looking pretty good. Now, this is one big multiplication term, which consists of 2y and x plus 4. And this is 5z and x plus 4. So you look at those two parts and say, is there anything in common between those two now? Yes, they both have an x plus 4. So you factor out this x plus 4, and that leaves you this 2y and this plus 5z. And now you have two binomials. And if you're like, well, I'm not sure I'm going to get that, okay, be sure you multiply this out. And if you multiply this out, you will get the original question. If you have plenty of time on your test, before you have to turn it in, it would be to your benefit to double check it and to multiply it out and make sure you did the factoring correctly. It'll save you some partial credit. All right, because I always tease my students and say, if you don't check your work by multiplying it back out, I feel like I should take it off twice, right? Once for you being wrong and once for you not checking it. Wouldn't do that. Okay, but really, you should double check your answers before your teacher gets to it. Saves you points. All right, let's do another one. So we say, okay, there's 4 terms. Maybe factoring by grouping would be a good choice. Is there anything in common all the way across all 4 terms? No, they don't all have an A or all have a B. 4 and 7 won't go into everything, so no. And there's no like terms to add together, so this is it. So we're going to look at the front 2 and the back 2 and say, well, there's an A in common in the front 2, and that would be B minus 7, because A times B is AB, and A times minus 7 is minus 7A. What's in common in the back 2? A 4. So factoring out of 4 gives you B, because 4B divided by 4 is B, minus 7. And be sure you multiply these out to see if you're right with this plus 4. Remember, most all the time it's this number. Now you say, is there anything in common between the front and the back set? Yes, there's a B minus 7. So when you factor that out, that leaves you this A and this plus 4. So these are your factors. All right, let's try another one. 3A cubed B squared plus 6A cubed plus 9AB squared plus 18A. And you're like, well, that's kind of more complicated. They're not like terms. I can't add any together. Is there anything in common to factor out? Make it a little bit easier. 3 goes into everything. And each term has at least an A in it. So I'm going to say 3A. And that would leave you, let's see, 3A cubed B squared divided by 3A would be A squared B squared plus 6A cubed divided by 3A would be 2A squared. And I don't know if it would help you to run underneath here and say I'm essentially dividing all of these by a 3A to see what's left. Maybe that would help you to decide what's going on with the powers. So 9AB squared dividing out of 3A would be 3E squared plus 18A divided by 3A is 6. That's a little better looking, right? Now, again, as I've said in other videos, sometimes people get invested really heavily into the more complicated part and they just forget about this part we've already done. So I suggest that you write a little note, maybe draw a little arrow down that says, don't forget the 3A while we concentrate on this part. So let's look at these 4 terms. Doesn't look like there's anything in common that I missed, so I think we're good. What's in common in the front 2? An A squared. And that would leave you B squared plus 2 plus. What's in common in the back 2? A 3. B squared plus 2. If this is going to work, there has to be something in common between this front and the back. And so B squared plus 2. Bring down this A squared, this plus 3. And don't forget the 3A we found earlier that we made that little note about. Okay? You can see why if you don't kind of make this draw the attention, you might forget about it in the rush. Let's try x squared plus 4x minus 3y squared plus y. And you go, well, there's no like terms to add together. There's nothing in common in all 4 terms to factor out. Let's look right here. There's an x in common, so that would be x plus 4. And there's a y in common. So if we factor out the minus y, we would have 3y minus 1. But I don't see anything in common between the front and the back. So you could try to rearrange things and go x squared. Maybe if we put the 3y squared here and the 4x and the y, there's not even anything in common at all. All right. So after you play around with this one and investigate it for a while, it turns out this one does not factor. And how do you know for sure? You don't really know absolutely positively for sure with these. You just check everything you can and all sorts of different combinations. And when it doesn't get to where you have anything in common right here, then you say, well, okay, I guess it doesn't factor. Let's try this one. All right. No common factors. Do you see anything to factor out? No, 27 is not even, so it can't take a 2 out. No, not all of them have x's, not all of them have y's, so I think this is it. What's in common in the front two? 3x. And when you divide that out, that would leave you 4x minus 9. We're going to bring out a minus 2 because they're both even y. So negative 8xy divided by negative 2y would be a positive 4x. And 18y divided by negative 2y would be a negative 9. Now let's check that. This kind of maybe creeps you out just a little bit, so let's check. Does negative 2y times 4x get you negative 8xy? Yes, it does. Does negative 2y times negative 9 get you a positive 9y? Yes, it does. So it won't hurt you to check all of these, but we're just checking that one at this moment. Anything in common between the front and the back? Yes, a 4x minus 9. And you bring down the 3x and the minus 2y, and you're done. All right, hopefully you're hanging in there. All right, let's do another one. 2m to the fourth plus 6 minus am to the fourth minus 3a. So there's no like terms to add together. There's nothing in common to factor out. So what's in common in the front two? A 2. And when you divide that out, you get m cubed plus 3. What's in common in the back two? Negative a. And that would leave you m to the fourth plus 3. Did you see that change of sign? Are you okay with that? Did you mentally come back in here and check these out? Okay. Makes me feel good, though. They both have an m to the fourth plus 3. So factor that out. And you'd have 2 minus a left. Now, this next one's a little kind of a variation of this. I've seen this in books. They sort of throw one of these in every once in a while. And some teachers like these. So this is something you might see on like a test or something just to see. I don't know. It's kind of like a challenge question. All right. So you look at it and say, well, it's 4 terms. There's nothing in common to factor out. Maybe I should look at the front 2 and the back 2, and you go, okay, there's an x in common in the front 2. There's nothing in common in the back 2. Kind of looks like the difference of 2 squares, but that's not going to help me because I'd have 3 minus 2y and 3 plus 2y, but that doesn't have anything to do with the front, so that's not getting me anywhere. You know, this front part right here, if the minus 4y squared wasn't there, that x squared minus 6x plus 9 would be a perfect square, right? A binomial perfect square, which was in just the immediately previous video. So let's just try that for just a second, see what happens. So you have a square on each end. What's the square root of x squared? X. What's the square root of 9? 3. And you use this sign right here. and say you're going to square it. Now remember, you had to check these. And what you had to do is go x times minus 3 is minus 3x. If I double it, does it show up right here? Okay, yes it does, and so this is correctly factored. Minus 4y squared. Okay, now can you see this as the difference of two squares? So that this minus sign right here is your difference, and here's a square, and this second term is a square. Okay, how do you factor the difference of two squares? I'm going to change these to squared off so you can kind of see where we're going. The square root of x minus 3 squared is x minus 3. The square root of 4y squared is 2y, and one's plus and one's minus. So I can take these inner parentheses off and say it's x minus 3 plus 2y times x minus 3 minus 2y. And if you multiply that all out, you will get back up to the beginning. And if you don't believe me, you should check it out. Okay? Now I promised you one that has something a little bit in there that sometimes students tell me they just didn't know what to do with it. Okay, even though almost I can't remember a time it didn't work one of these in class, but you know, sometimes when you're in class, you're tired, things go by so fast you just don't notice it. But this is something that does happen fairly frequently, and so you need to know what to do when this happens, right? So you say, well, there's nothing in common to factor out. There are no like terms to add together. What's in common in the front two? They're both even, so 2, they both have at least an x, and that would have you 3x, right? Because you're dividing essentially by 2x plus y, right? Okay, what's in common in the back two? Well, there's nothing in common between a 3x and a y, is there? But in order for this factoring by grouping to work, you have to factor something out, even if it's just a 1, because won't 1 go into anything, right? Any number is divisible by 1. So what you in effect do is you go through here and divide by 1. You have to have a number to factor out. And here's your 3x plus y again. So when you're doing this process, if the only thing that's in common is a 1, you have to actually demonstrate the 1. You have to show the 1 so that when you do this, you bring down this 2x and you bring down this 1 right here. If you don't show the 1 and you just go, okay, it's got a 3x plus y, there's a match, right? Then you factor out the 3x plus y, you bring down this 2x, and then you bring down, well, there's nothing there. What are you going to bring down? All right, so you need to have the plus 1, or you're going to have to remember that there's an understood 1 there, right? So that's the little thing I want to show you. It does happen more often than you would think that there's only a 1 in common. So do keep that in mind. Pay particular attention to that. And that's the end of this video. And don't forget that there are practice problems in the description, links to the other videos, and leave a comment, subscribe to this playlist, and I will see you at the next video.